Well, welcome. In this video, we're going to go ahead and make a key for the Unit 1 Study Guide pretest. So if you will go ahead and get your Unit 1 Study Guide pretest out that you have completed, let's see how you did, and we'll go from there. We're going to start with page 1 today. All right. So what you can use for this pretest is you can use a calculator if you want. Some of these questions don't require it. A little heads up, if you're looking at doing things in math, science, computers on down the road, calculators are nice. They do make things faster, but also having that number sense is really, really important. So use a calculator when you need to. When you're working with decimals, that's a good time to. Otherwise, hey, try to really, really work, especially in your early high school career, on working on your mental math skills, and you'll find yourself, if you do that, you'll be faster than in a lot of cases than those who are using a calculator for everything. So, but it's a tool, it's a resource if you need it. Just don't overdo it. So one of the things we want you to do in this first concept is we want you to be able to work with vocabulary. Try to figure out what's going on in a situation and just use some arithmetic to figure out some different things here. All right. So the answer to a multiplication problem, little vocab, is called a product. The answer to a subtraction problem is called a difference. The answer to a division problem is a quotient. And the answer to an addition problem is called a sum. So next, a 6-ounce can of tuna sells for 94 cents. It takes 5 miles to get to the grocery store, and gas is $2.09 per gallon. To the nearest cent, what is the cost per ounce of the tuna? And we have to show how we arrived at our answer as well. So when you problem solve in math, there's information that we don't always need. And so we see that here. The question we want to answer is, what is the cost per ounce of the tuna? So when we see cost, that's 94 cents, and I'm going to make a note of that. We want to find the cost per ounce, and what that really tells us to do is we want to divide that by 6. Now, we also have to round this to the nearest cent. That's important as well. Now, I could sure do this without a calculator, but since I've got one handy, I'll go ahead and I've done that. You see that right here. If I take 0.94 and divide by 6, this is what I get. Now I have to round this to the nearest cent. Well, rounding to cents is like rounding to hundreds. So this 5 is the cents place. If I look to the right, and the number to the right is 5 or larger, then the cents place will round up. So my options are 15 cents or 16 cents. And in this case, it's going to be 16 cents. And I can write that in dollars, or I could write that as 16 cents. Since we're kind of talking about rounding, though, and we tend to use a lot of dollars and cents together, the first one might be better. We could also label this per ounce if we wanted to, too. All right, a local professional football team had 624,392 fans in attendance for the entire regular season. To the nearest 10,000 fans, how many people were in attendance? So rounding to 10,000, so that's where this 2 is. We look to the right. We'll notice that the number to the right of the 2 is less than 5. So that final answer, that 6 will stay, that 2 will stay, and everything after the 10,000th place will become zeros. 620,000. Number 4, explain why the value of the square root of 47 is closest to a whole number of 7. Well, if you think about square roots tell us, and what we're looking for is a number that we can take times itself to get 47. So I know that, well, the square root of 36 is 6. And the reason for that is because 6 times 6 is 36. Now, I also happen to know that the square root of 49 is 7, because 7 times 7 is 49. All right, so if I were to explain this, here's what I could do. I could say, since 47 is closest to 49 rather than 36, then the square root of 47 is closer to the square root of 49, which is 7. 36 and 49 are called perfect squares because 6 squared is 36 and 7 squared is 49. Let's move on. Comparing. So we've got less than, greater than, equal to. Think of things on a number line. So on a number line, if we have negative 2.3, negative 2.48 would be farther to the left. Therefore, negative 2.48 is less than negative 2.3. And we think of a number line as anything farther to the right is greater, anything farther to the left is less. Now, we have the square root of 38 and 6 here, and we have to compare those. Well, what we see using the reasoning up here on number 4, we know this is going to be greater than. So one other thing I can do is, in a situation like this, I could use a calculator to calculate the square root of 38. The way you would do it on this calculator is the square root button is right above this key right here. And so the way I'm going to access the square root is I'm going to hit second, and then I'm going to select the x to the second key. And I'm going to type in 38, and you'll notice I get an answer that's above 6. Now, here we have to place the numbers in order from smallest to largest. So let's see what we can do. First of all, this is an improper fraction, and improper fractions are, hey, they are a-okay if you want to leave things improper. But when we're comparing, there's situations where mixed numbers are okay. So a couple ways we can do this. 1, 4 goes into 13 3 times with 1 left over. So this is the same as 3 1/4. The other thing I can do is I can take my calculator using this fraction key, and I could hit 13, and I could hit this fraction key, and a 4, notice it, that's what it looks like there. I can hit enter on that, and it'll give me the mixed number 4. What I can do too is I can hit the fraction key again, and in this case, I didn't quite like that, because what I would need to do is I would need to go ahead and select one of these other options up above here. So I'll try that again, 13 fourths. And if I hit second and the same key again, it's going to go back and forth. Okay. Every calculator is a little bit different with that. All right, so -2. Now you're not going to change. Now the square root of 5. Well, I happen to know that the square root of 4 is 2. So the square root of 5 is going to be greater than 2. But not much. Now I could put that in my calculator again if I wanted. Here's a half. Here's -3 halves. That's the same as -1 1/2 because 2 goes into 3 once with 1 left over. And 9/14. Well, if I look at 9/14, I could put that in a calculator. I could see what the decimal is for that. 9 divided by 14 if I wanted to. So 9 divided by 14. And I'll see it's a little bit over a half. But I also know that without a calculator because half of 14 is 7 and 9 is more than 7. So 9/14 is more than 7/14. So I'm going to put a little note. This is greater than half. Now I'll put them in order. So smallest number I see is the, let's see, number farthest to the left. That's going to be -2. I'm going to check that one off. Then we've got -3 halves, the other negative. And when you put things in order, you always want to write the numbers that they originally were listed as. Let's see, fractions. We've got half. We've got a fraction more than half, 9/14. And then we've got the square root of 5, which is a little bit more than 2, and 13/4, which is more than 3. Having number sense is the ability to not only to be able to calculate maybe very quickly in your head, but also you get a feel for what the answers are going to be too. So 8 says the sum of a positive number and a negative number will always be positive. Give an example to show that this statement is false. Well, if we have a positive number and a negative number, if we had a situation such as, let's do this, 10 plus negative 12. Now, sum means add. And if I add a positive number and a negative number, it will always be positive. Well, not in this case, because I have more negatives than positives, so I end up with -2. Finally, a positive number decreased by a negative number will result in what type of number? Well, let's think about this. Let's give a situation. A positive number like let's say 4. Decrease means to subtract by a negative number like -3. Well, when we add the opposite, which is the procedure we use when we subtract integers, we're going to get a positive answer. Does this always happen? Well, yeah, if I pick any positive number and decrease it by a negative number, what I'm doing is I'm taking those negatives away, and so I'm going to have more positives when we're all done. All right. Well, that's page 1 of the study guide, and in the next video, we're going to continue on with the next page. So we will see you next time. I'm going to go ahead and shut this off, and hey, we'll see you in the next video.